Hello everyone, good evening. So welcome back to the Tech Track. Today we'll be having our speaker, Miss Machi Davis Obodo. Miss Machi is a statistician and data analyst with experience in statistical analysis, research methodology. Her area of expertise include descriptive and statistics, hypothesis testing, regression analysis, survey data, and research design. She's passionate about data analysis and she likes making it simple, accessible, and she likes helping beginners build practical skills and confidence while using statistical softwares. Ladies and gentlemen, let's welcome Miss Machi. Catherine, the floor is yours.
Right. Good evening, everybody. Good evening. Welcome to today's session. So I'll be sharing my screen, but before then, sorry about last week. The network was very terrible last week. Hopefully, it's not going to be the same today. I believe it's not going to be the same today. So sorry that I left the call very abruptly. Okay. So I will share my screen. Sorry. Um, Very difficult to. Okay, so can everybody see my screen?
Yes,
Can you see my
screen,
screen? Okay, thank God.
see your
Thank
screen,
you. Okay, thank you. All right. Okay, so last week we were, if you remember, I think we were basically trying to. Yes. Can you hear me?
Yes, I can hear you.
Okay, thank you. I heard somebody, so I was thinking I wasn't being heard. Okay, so I was saying that last week we basically tried to explain what data would do for us as people in radiography, researchers in radiography, and also to see reasons why we're trying to see statistics and reasons why we're trying to use it in research. So this time around, we're going to like basically dive in because those were all like peripherals. I would also we'll also be making it's also going to be an interactive and practical class so that we can get to use the software that I had sent. I hope everybody has it. Anyways, but before then, I just want us to um kind of understand what we are, the kind of data we're going to be seeing as when we are throughout the course of today and probably other classes, because it's good that we know the kind of data we are dealing with, because on SPSS sometimes we can meet or PSPP, we can meet roadblock when we don't understand the kind of data we are dealing with. So normally we have three ways that we measure data, or three common levels of measurement of data. So data can be, let's say, classified into three. There's nominal data, there's ordinal data, and there's scale data. Right? There's nominal data, there's ordinal data, and there's scale data. So for a nominal data, you have, like it's written here, data divided into distinct categories. So now sometimes you would hear that data is divided into two, that is categorical data and is continuous data or scale data. That's true. But now in categorical data, you have two types of categorical data. But just not to speak too much English, there are three categories of data, or three levels of data, or three measurements of data. And it's nominal, ordinal, and scale. Now for nominal data, the data is divided into distinct categories with no inherent order. So now categorical in terms that it can be a date a data that has different subsets. So now, for example, when we're talking about gender, we would always say male and female. So it's categorical, but it's nominal because you don't place anyone higher than the other. If I want to code that data now, and I think we know what coding a data is. If I want to code it, that's if I want to turn it into numbers, I would not say that there's no particular order. That's why I have to write it down so I don't forget that I'm calling female one and I'm calling male zero, or I'm calling female one and I'm calling male two. I have to write it down so I don't forget, because it's not standard anywhere. If that coding goes to somewhere in Russia or North Korea, or I don't know, South Korea or Japan, the person that sees data is not going to know that, okay, one in this gender slot means female. Person will not automatically know. You have to maybe have written something for the person that, okay, one is this, two is this. So that's what makes it nominal, is that it doesn't have an inherent order like that. The same thing with blood groups, the same thing with even when age is categorized, like there's some questionnaires or surveys that people pass around that you'd see when it comes to what is your age. You don't want you to write a figure for them. They tell you, do you belong to a group of 0 to 18, or do you belong to the group of 20 to 35, or do you belong to the group of 36 to 38? That way, to some people, you can either, I don't know, that one can be a little bit ordinary because you're like, okay, use your head and just say 0 to 18 is 1, and like that and like that. But you can still do it however you want. So yes, blood group, and we can think of many others that have that kind of category. It can even be profession. Like if you take a survey of a hospital and you ask for profession in it, and you want to know whether this person is a doctor or a nurse or whatever, or I don't know, a videographer or whatever you can say, you're not going to start saying, okay, the doctor is higher than the nurse, so I'll give the doctor number one, and the nurse is higher than, no, that's not how it's going to be. But now when it comes to ordinal data, it's a categorical data with a logically ranked order, but on equal intervals. So for example, when we do surveys that have Likert scale questions. Likert scale, I mean, is that questions that have some sort of range, like from low to high. So there's low, there's medium, there's high, or there's poor to excellent, like it's written on the screen, or there is the popular one that we have is I don't remember it now. Most likely to, maybe you're asking, I don't know, you're taking a survey of, you're trying to see what makes people go into smoking addictions or something, and you're asking the question of, are you most like, do you prefer, or would you take 1 or 2 cigars in a month? I don't know, those kind of questions. You're expecting that the person says, okay, I will most likely do it, or I will not most likely do it, or I will not do it at all. So those are like skill questions, questions that have degree unequal degree sometimes, but like they have some degree. And in those cases, you have to number it accordingly. So now, if I have a question where the answer is supposed to range from disagree to moderately agree or highly agree, I don't remember the adjective or adverb that is supposed to be there, highly agree or whatever. Um, if I go and say disagree is one, I'm not now going to go and say number two is highly agree, and number three is highly disagreeing. I don't know. There's a way that it's looking. It has to follow a sequence. That way, you get more accurate output, and also you don't confuse people that are looking at data, and you don't also maybe confuse the system that is trying to analyze the data because there's rhythm and there's flow. Okay, and of course um we have the scale, the continuous variable. Now these are the ones that are not categorized. So most times you don't have to code a continuous variable because it's numerical, and it has, what it has is that it has its highest point and its lowest point. So like your age, like age, when you collect weight, when you collect blood pressure, when you calculate body mass index, all those things, waiting time, radiation dose, all those things, they are numerical values. And we know the kind of descriptive statistics you can get out of that. That's a mean, median, mode, variance, and standard deviation, more or less. So it's good that we have an idea of what more or less the data that we come across, where they fall. It helps us it helps us when we even get to hypothesis testing. It helps you to know which tests am I supposed to use for this kind of data that I have, but we'll get there. We'll get there. Okay. All right. So I can move. Where am I? Okay. So before we get there, I would share this. We can open our PSPP. I would also open mine here so that we see. I just want to take us through the interface, then we'll continue. I believe that we know how to open it, right? Okay, let me share my full screen so that you can just see what I'm doing. Okay, mine is easy to see, right? So I'll just go. Oh my god, with this. Okay, please can you can tell me if your own is already opened on your screen, or and if you can also see what's on my screen. I just need one person, so I'll go ahead. Or two.
I can see it.
Okay, you can. But do you have your laptop with you? Is yours opened?
I can see yours and mine is open.
Okay, great. Any other person? Okay, so I this is basically what the interviews will look like, and if you've ever seen SPSS interviews too, it's not very different. So basically, I'll just like take you through what it would generally look like. You'd have your variable view, and you have your data view. Now, and when we import a data inside, your data has comes up in two views. The data view would show you more or less how it would, the same way it looked in the format you're collecting it from, like maybe it was in an Excel sheet. Most likely it's going to be an Excel sheet. It's going to look like that the same way when it's in data view. You'd see all the columns and all the rows. And remember that your rows, that's this horizontal here where my mouse is going to, this horizontal here, are your observations. So like if you're when you get your survey question, which I know we already know, your columns would be the different questions that you have there. Then your rows are, you're basically imputing each observation that you've collected. Like this person, this person, this person, this person. Those are your rows. Okay. Then variable rule basically, you can already see that it already has more or less like its own header, unlike the data view. So it's more or less explains the data to you, data that you've put inside. It tells you what kind of data it is. It tells you if the data is in numerical data, that's a continuous data. It tells you how many decimal places it is. You can also adjust decimal place there if you want. Most times I just prefer to not put a decimal place. But if the data already comes with decimal place, it tells you how many decimal place it is. And if there's an error there already, like maybe if you were supposed to import a data that doesn't have decimal place and it's telling you that it has decimal place, you'd adjust that. Like I said, it tells the type of data, and also in this view, you get to label the data. Now, SPSS and PSPP can run a data that hasn't been coded sometimes, but other times it doesn't understand the uncoded data. So you have to code it either in Excel and import it here. But now if you import it just like that, you can also code it here. But I usually prefer coding it in SPS. Now what I mean by coding is that where you have English, those are visitors, where you have the data that you've collected. Like now, some people don't already get, like when they collect their survey questions, or maybe they use Excel to collect it, and not Excel, Google Forms to collect it. So now Google Forms doesn't change your female to 1 or your male to 0 or those kind of things. You more or less do it manually. But now, if you are giving out hard copy, what they call it, hard copy survey questions, I believe that when you're imputing it, you're already trying to impute it with the codes in mind. You're already trying to impute it with the codes that you have in mind, so that you don't have to do double work of changing it again. So yes, so now when you come to SPSS or PSPP, you would see that this place that has value labels, you have to now tell the SPSS, what does that one, the one that it's seeing, what does it mean? And the two that it's seeing, what does it also mean? Everything that you have labeled, you now have to describe, almost like you're describing the data to the SPSS. So when it brings out its output for you, you're not looking at strange things. You can more or less navigate it. Okay, so I didn't do this, but I would send the Excel sheet that we are going to use to the group. Sorry if I do that. Okay, so I'm going to share the Excel sheet that we would use while we're doing this. More or less see how to import. So I've sent it. Okay, sending. I've sent it. Okay. So I've sent it. Should be coming in anytime soon, so that we can work on it. Okay, has anybody seen it? Well, it has sent. Don't know if you've seen it already. Should be seeing something like this.
I've seen it.
Okay, great.
It's on the WhatsApp page now.
Yes, on the WhatsApp page. Yes, thank you. Okay, so more or less, okay. Are you doing what I'm saying? Has any other person been able to open it? Anyways, okay. So for the record, I was looking for
I've
a
opened it
data
as,
really.
open it as well.
Okay, thank you, thank you. But and you can also see it on my screen. Okay, so I was looking for a
Yes,
data
I can see it
related
on
to
your screen.
videography. You can see it on my screen, yes, thank you. And I think it's a bit difficult. I don't know when you guys like do surveys. I don't know whether anybody tries to put it anywhere because like the data is very scarce. Where the ones that you see are like picture data, and I didn't want those ones. Anyways, I finally just got the regular healthcare data, but we might need to impute some scores here, but we'll do that eventually. That would help us like in other things that we want to do. Okay, so this is basically what your typical data looks like. Now, if I import this into SPSS, it's still okay, but I want us to try to code it a bit here so that it's easier for us when we get to SPSS. Even if you can still do whatever you want to do on SPSS. Okay, so now what I mean by code is that we are going to change all these what do you call it now? We're going to change this in gender. You're seeing the gender column is the second column. We're going to change the female to 1 and the male to 2. That's what we're calling it. So female is 1 and male is 2. Please let's not forget female is 1 and male is 2 because we're going to change the number now. And for all these places that have NHIS, false, true, false, true, false, true, we're also going to give it a code so that it would be easy for us. Okay. So normally what you do is just like control F to find and replace and go to F and what do I want to find? I want to find F and I want to replace it with 1. I want to replace it with 1 and I replace all. Okay, now I have a problem there. Let me do control Z. Sorry. Hi, it's a lot of data. I should have stopped. Sorry about that. I don't think we should do that here too. It's a lot of data. I was going to copy a bit from it and paste it somewhere else because the number is a lot. But now it's doing it for everything and it's going to take time. Okay. See, people, Jesus Christ. Okay. Sorry. Control Z. Aye, aye, aye. Okay. Anyways, when by still trying to undo what I did. Yes. So now from here we can see that of course we've seen that there's a nominal data here in the male and the female, and for age we can see that it's a continuous variable. Okay, it has come back. So now what we can do just copy out from the heading, that's the variable names, right? So like the first 20, just the first 20 or 25. Okay, so that we use just that because the rest is a lot. So copy from the variable name, please. The variable name. You can create another sheet in the same Excel sheet and just paste it there. Okay, great. Okay. Please, whenever you lose what I'm doing, just tell me. So now we can code them here now because it's a bit smaller. It won't take too much of our time. And the mistake I made was that I was going to code F. But if you see that false starts with capital letter F. And once I want to code it, it would code both the F of the gender and the F, except I highlight. So what I'll do is that I'll code false first, false and true, so that I don't have an interruption there. So, or you can just highlight the one you want to do and code it. So, for false and true, we can say true is number 1 and false is 2. So we are coding true number 1 and false 2. Let's not forget this coding. Then we are coding female 1 and male 2. Okay, so I would come and I'll do Control F again, and I want to replace. So I will code for true 1. Replace all. It replaces it immediately, and I will code for false. Right. And replace all. Great, thank you. So now when we are to also know that I'm very sure we've done this before, but like Excel, you have to use exactly how it's seeing it there. So if it falls in capital letters, better to like use it as. Yes, sorry, yes.
Please, ma, let me interrupt you a bit. Okay, in this coding now, did you just need to highlight this part and now click Control F?
Okay, I was saying that you can highlight the part you want to do and click Control F, or you can just click Control F and make sure that you put exactly what you want to code there so that it just reads that one. I don't know if you understand.
No,
Like what
I
I
don't.
did, I didn't highlight. I just did Control F, and I went to replace because it's yes, and it's replaced. So I impute what I want to replace, which is what I want to find, which is false, and I want to replace it with number 2. Then I put number 2 there.
Okay,
Do you have
you
an
just
issue?
do the coding. You just do the coding at random and
Yes, because I want to
and
replace all the false that is in this 25 observations that I collected. If I wanted to leave some and keep and do some, I would have highlighted the ones I wanted to do. But since I wanted to replace all of them here, I decided to not bother highlighting anyone.
okay, ma.
Yes, do you understand? Okay. Are you trying to do it?
Yes, ma.
Okay. You can tell me when you manage. Who else is? Let me find this.
Yeah, I've done mine.
Okay, you've done yours. Okay, nice.
Okay, but what I did was I highlighted for sex because that was what I was doing first. So I did find and replace for sex first. Then after I removed I didn't highlight again, and I did my false and true replace.
Okay.
Then it replaced every other thing.
Okay, yes, that also works. So the person that asked the question, you can also do that if you want. You can highlight. It doesn't really matter. Okay, so since you've done for your female and male, let me also do mine. We said female is 1, right? F is male is 1. Okay, yeah. Okay, so yes, that's all right. That's fine. So we can save so that we don't lose that. Okay, so now I'm going to go back to my PSPP so that we import this. I have a bit of a problem. Import this thing there.
I did Control F and it's showing me a dialog box.
Okay.
Find what?
Yes, so you have to put what do you want to find? You want to find false, right? And you want to, is it also showing you replace? You would also see something like, let me put my own back. If you see my screen, is it this?
Find and replace.
Okay, find and replace, exactly. So are you seeing my own screen? Do you see how it looks here?
Yes. Okay.
Does it look the same in yours?
Okay, you mean this coding?
The dialog box that came out. I'm trying to help you out. So I want to know whether this same dialog box is what you're seeing on your own screen.
Yes, it's the same dialog box.
Okay, so what's the problem?
Okay, so in the replace, I should type what I want in the replace and find.
No, in the find what, you type what you want to, that's false. Maybe you want, let's start with false.
Okay.
So you can type false. Yes. In the replace, in the find
Okay,
what. Yes, then in the replace,
okay.
we said that false is, what did we say false? We said false is 2. So you can say replace with 2.
Okay.
Yes, then have you done that? You can now go beneath the last row there, you see replace all. So you click it and you should replace your false with 2.
Yes. Okay, yes,
Exactly.
it has done that.
It has done that. Good.
Okay,
So you do the same thing for your
true.
For true and for F and female and male.
Oh, that's great. Yeah, I've got that as well.
Okay, also do the same thing for gender. You can highlight the gender.
Okay.
I think it's even better because it's causing me problems now. Okay, so when you're done, you can let us know. Okay, but while we are at it, let me be going to my. Okay, so I'll go back to share my
Sorry, are you the one that added serial number to your data?
Yes, I was the one that did that. You can add to
So
it.
we can add, all right.
Yes, you can. Okay, so are we on the same page now?
Yes, we are.
Okay. All right, great. So are you done coding what you were coding?
Yes, I am.
Okay, so nice. So we can go back to our PSPP because we're going to try to import the data there now. Okay, so now here, when you want to import, you can go to File, and you see New, you see Open, just those ones, and we can talk about it later. Just go to Import Data. Okay, so are you ready?
What is the import data? I didn't see.
Okay, sorry, let me go back so that you see what I did. You go to File, you see your what do you call those things now? Menu bar. You see File, the first file there, the third thing on the list is import. Exactly. So you click on Import Data.
Sorry, is it if we click on the file to the import to come out?
Yes, if you click on File, a drop down list to come out.
Okay, no, it's not showing on what you're sharing, and by the time we minimize, we won't even see what you're doing. Okay, let me go and do that.
But it's not showing on what I'm doing.
No, the drop down is not showing on the screen you're sharing, but I'm seeing your cursor on your file. I think maybe it's network or something. As in the cursor is on file, but the drop down
is not showing.
Yes.
That's a problem.
Maybe it's network or something. Don't worry. At least we understand what you're saying.
Okay. Okay, so yes, so you go to file, then you go to import data. Import data should be like the third thing that you see when you when you click on the file.
Okay.
Are we there? Okay. So now because I you see my screen now?
Yes.
Okay. So because I have okay, so nice. Because I've opened this data recently, it's showing here, but you'd have to like look for where yours is saved. I want to be able to save somewhere in downloads because you downloaded it. I believe that's how it works. So you can go to your downloads and you see this file that we just tried to code. Then you can click on it. Are we there?
Please, when you click on it, like mine, if I click on it, it's showing me. Let me click again. I have all files, reset, next, cancel. What do I say?
Oh, yeah, so click on next.
Next.
Yeah.
Okay.
So you click on next, you'll be on the same page that I'm on rather.
Oh, this minimizing thing. Okay. I'm in the place saying select the lines to import all files. Yes. Okay.
Okay, so now it tells you that the amount to import. Now, if we were using that the first sheet of that data, we would more or less do like only the first 100 only because the first sheet of data had almost 60,000 observations collected. But let's just leave it at what is clicked there is all cases. So let's leave it at all cases. I want to see what it would bring. So we can click next.
Okay.
Yeah. Okay. So it brings out the 26. That's the one that we've coded. That's what's on your this thing, right? It brings out like what does it bring?
All those plenty things through false is also there.
It's still showing through false.
You know, I created a sheet like the second sheet for what we copied.
Yes.
How do I let it know that it's sheet 2 that I want, not sheet 1?
Not sheet 1, yes.
Because they are saved in the same name. Yeah.
Okay. Come, give me a second.
Yeah.
Yeah, I can't find my own file.
Sorry. Where did you? Can you check your downloads?
Where did you save it? Like I saved mine in desktop, so I went to desktop. Wait, where did you save yours?
Okay. Let me check. It might be on my desktop.
Okay, yes, you can do that. You can also try to go to your folder on your laptop and see where you saved it.
Okay.
Yes, that would help you to like know where to import it from. Sorry, I'm coming. I want to answer the question you asked me.
All right.
But on your screen, you're not seeing anything to help you choose the second sheet. It's supposed to show there. Like, if you... Okay, I'm coming. Sorry, the person that was looking for their file, have you found it? That's okay. Is there any way that I can see what's on your screen?
Okay, should I share my screen?
Yes, I want to see what is showing you. Because I don't know, me, it just takes me directly to where I need to be.
Okay, may need to help me. I just clicked on the share screen, so a dialog box came up. And showing me share. Okay, share, cancel. I guess. Oh, there's not even choose what to share with Google Meet.
Share
entire
the
screen.
no, go to Windows and try to share that particular.
I should click on Windows.
Yes, you see Windows beside the share entire screen. Then try to share just the place that has the.
Okay, I've clicked on Windows. Then I click on share.
Okay, you found your file. Thank God.
Yes.
Okay, I've clicked on Windows, but the share button is not. To share or to share a tab or even screen instead. The share button is not coming down, only the cancel button is active. What am I supposed to do?
Have you click on the when you click on that Windows, you'd see different windows that opened on your laptop, right?
Okay, yes.
So click on that PSP one.
Okay, select first. Okay. Okay.
Yes.
Okay.
Thank you.
Import my own file. I've seen my file.
Okay. So remember when I said you should look for import data?
Yes, I have done that.
Okay.
I've gone to the file.
Okay. So have you opened it?
Yes, I've clicked on the file.
Okay, so click next. You'd see next at the bottom of that page. Meanwhile, Priska, I think you also click next.
Okay, I've clicked next.
Yes.
Are you seeing my screen now?
Yes, I'm seeing your screens ready.
Okay, I'm having show my screen anyway. Stop presenting. I should click on show my screen
So
anyway.
just leave it. I'm seeing your screen. So now you go back to your PSPP on your laptop. Don't worry about what you're doing. Because that's what I'm seeing.
Okay.
So just click next on that PSPP. I want to see what it shows you.
Okay.
Okay, ma, I've clicked next on mine.
Okay, so what are you seeing now?
Okay, I've seen a window that open. Select file to import. Select the lines to import. Select the first line. Choose separator. Adjust variable format.
Okay,
That
but
is
what
by
are
the
you?
side.
And yes, what are you seeing on the main screen?
On the main screen, amount to import. All cases. Only the first. Only the first. Select the line to import. That is what I am seeing as the.
What are you said you're seeing? Are you seeing what's on Priska's screen? Is that what you're seeing on your own screen? Priska said you can click on next.
Okay, next. All right.
Let me see what you can do.
I just did.
Okay, scroll down. Supposed to give you still showing just you. Are you sure that other one is on the same sheet that you have?
Yes, I just added them sheets.
Let's see, because you're supposed to show that there are two sheets there.
Should I, if I open that one, will you see it?
I won't see it because you're not sharing that one, but you can. What can you do for me now?
Just confirm. Is in sheet 1. The main work is health care, no shows. Then I added sheet. I click on that plus. It gave me sheet 1. I copied and pasted in sheet 1. So that one is in sheet 1 in this same file.
Thanks. Okay, coming. I need us to move, but you guys are not on the same page with me.
Okay, so what do we do so we can move? Should we maybe ignore it and just use your own screen? Maybe at the end of the day, we can sort it out or you tell us what to do.
Okay, I think that's what we will do, right? So that we don't take too much time.
Yes, ma'am.
Okay, thank you. So let me go back. Actually, you can stop sharing your screen. Let me continue sharing.
Okay.
Yeah, thank you.
You're welcome, ma'am.
Yeah. Okay. So I'll go back to my own screen. I would come back to the problems that we're having. So sorry. Okay, so file, I'll go to file and I want to import data. And we already tried to do that. Mine is this one here. So I would do next. And I don't mind having all the cases. So next, so it comes out like this. I believe you're seeing my screen. This is what it comes out as, and you can see that I have my 26 data here. And after that, I also do next again.
Sorry, your screen is blank on mine. I don't know if it's my network. Is any other person seeing?
Is any other person seeing my screen?
Yes, I can see it. I think it's network.
Is there values? I'm seeing the screen. Is there values on it? Can you see any value?
No
I've
value,
seen
no value.
but there is no drop down. The
No
thing
drop
she's
down,
clicking,
no
the drop
value.
downs are not showing.
And no value, because she just said now that the values are here. I've not seen any value.
You're not seeing it?
Yes, ma'am.
Okay. Okay, let me share my entire screen then. Okay. Can you see this one now?
Yes.
Yes, we can see this one. Yes.
Okay, let me go back. So I said file. Can you see this import data?
Yes, it's
Yes.
coming up now. Yeah, it's more
great.
likely.
Good. Okay, so I chose the first one there because that's what I'm going to use. So next, and I will leave it at all cases because I have the exact number that I want there. Then now it says that select the first line of the data file that contains data. Line above selected line contains variable names. So I would select this number 2 because I want it to know that this line that has 1 where my cursor is here, these are the variable names. These are like the column names I want it to give. So I'll just put my cursor on number 2. So I'll also click next. So now it basically arranges it how it's supposed to be. So you can see appointment ID, gender, it's arranged like in a tabular form. And I just scroll through the data to be sure that that's what I want it to look like, right? And I can now see next again. Then it shows me still that this is what it would look like in variable view, and this is what it would look like in data preview. Sorry, someone saying something. Okay, so basically, and I'm okay with it, so I'm like, okay, yeah, apply. So it imports it here. So now this is what your imported data should look like in SPSS, more or less. Is what it should look like. This is the data view, and this is what your variable view looks like. Right? Sorry. This is what your variable view looks like, and this is what your data view looks like. Okay, so now those two questions that we had, or those couple of questions that we had changed to numeric, we are going to let SPSS know what's the value we have given it. So we'll go to value labels, this column here that says value labels. I just highlighted it. And you go to in your variable view. Now in your data view, you're not going to see that. You're just going to be seeing the numbers and everything. But when you go to your variable view, you'd see gender is in column 3, and you go to value labels, and you can click 1. When you just click it, a dialog box comes up, right? So remember that we said for gender that 1 was female. So female, I'll tell the doctor that 1 is female, add, and 2 is male, add. Then I can click OK. So it stores it there. It stores it that 1 is female and 2 is male, right? Then what else did we change? We changed NHIS, basically everything down from here, NHIS, hypertension, diabetes, alcoholism, and the rest. So I would go to NHIS, the same thing, sorry, here. And we said 1 was true, right?
Yes.
Okay, 1 was true, add, and 2 false. add that too. And okay, so that was the I think I can copy this. Sorry. Okay. Anyways, I do the same thing for the next one. One is true and two is false. On this one too, one is true, and two is false. Okay, so you can stop here for now. Okay, so now let me go back to my PowerPoint. It's supposed to be here. Sorry. Okay, so in the last class I was talking about descriptive statistics, which is like how to more or less, if we have a data set that we want to, at a glance, what's the data set telling us? What can we say? Like this one now, this one that we have is a very small data set and doesn't have a lot of questions. We might want to know how many meals, how many meals are in this 25 sample that I collected from this data set, and how many females. We might also want to go deeper and ask ourselves that how many meals from these people that I collected said that they or have diabetes or have a national health insurance or have hypertension and all those things. And those are all things that we can look at. And we can also even also go to measures of central tendency and also see that with the age that we had gotten, because if I don't know if we try to look at the data set when we're working on it in Excel, you see that there was an age it was an age as little as 4. And I was asking myself, what's this thing doing here? And as I think as high as 60 something. So that's a very I don't know, large range of number. And I'm kind of curious. I'm like, okay, I wonder what the mean number is going to be, or the mode, or the median, the middle number. And so we can do all these things here. So now, first of all, let's try to find what percentage of male and female people we have in these 25 names that I had picked out. So if we want to do that, this same menu bar that we have up here, we can go to analyze. And when you click on analyze, you see a drop down tab. I hope you can see it. A drop down tab. And the first thing there is descriptive statistics. Like SPSS knows that like that's one of the first things that we do. So we can go to frequencies. Right, when we go to frequencies, we want to know the frequency of gender. Frequency of gender. So we can click on, we want to have a frequency table, right? Good, continue. And this is to give us this, it normally give us these statistics normally. So do we want any charts? For now, we don't. So let's just click on OK. So what SPSS will do is that it has an output, interface, like a different page for output. So it's just start loading the output at the background. To load the output at the background. So now see what it did there. You can still see my screen, right? It gives you an output view, a different page for output. So we're looking for the number, this last table that I just highlighted here. It tells you that female and male. Remember what we had imputed was 1 and 2, but because we labeled them, we said 1 was female and 2 was male, and we can see that it has accepted that our labeling and is now calling 1 female and the second one male. If not, what would have happened is that you'd have seen 1 and 2, and wherever you're taking this data to, you now have to like recode it to that, which might not be stressful for some people. Anyways, we can confirm that it did the complete thing because we imported 25 data set here. That's 25 observations to this SPSS, and the total that we have is 25. Now it's basically telling us that from the number that we removed from that data set, 20 people there are females and 5 are males. And the same thing with the percentage, 80% of the people that we those 25 people female and 20% male, right? Yes. Okay. Then that's for frequency. So basically, when you want to get the frequency of anything, if we had more nominal data, you'd be able to see that. So now another thing that we can try to find out is, okay, how many people, how many of these 25 or these 20 female people said that they have NHIS? That's they said true to this question of NHIS, and how many people said false? So we can do that by going to crosstabs. So crosstabs will come out like this. Crosstabs come out like this. And we want gender to be in our row. So we want to see male and female. Or it can be the other way around. You can want gender to be on your columns, or your remember columns are, let me go back and explain that to you. Columns are vertical. So this appointment ID is a column. This whole place like this is a column. This one I highlighted is a column. This gender is a column. Schedule day is a column. But rows are horizontal. So, and I was saying at the beginning that in columns you see the questions that you had asked, each question, each data that you wanted to collect. But in rows, what you see is each observation. So now person 1, these are the answers to these questions that he gave. Person 2, these are the answers to the questions that you gave her. These are her answers to them, like that. So that's how it is. Okay, so let's go back. So I was saying you go to analyze. What do we want to find out here? We want to see, we want to somehow not have to go and count, oh, I had 20 females and I want to know what each of them said about this thing of NHIS. Then, or maybe to also go and say, oh, I had 5 males and I want to know how many of them had hypertension. I now go and start checking the data. No, it's this one giving a tabular form, and you can just basically see the percentage. Okay, so I said descriptive statistics. Then you go to crosstabs. So you want to crosstabs. So I already put gender here. Then in the column I want to put NHIS, and I also want to put hypertension. So just for checking sake, I would go to statistics. I don't really want a chi-square, but still they want to give me no problem. And I'll also go to format. Okay. So it's telling me that's going to give me a print table. It's going to give me count, row, column, and total. Okay, so I'll click OK. Okay, so are we seeing what's here now?
Yes, ma'am.
We're seeing it, right? Okay, so now I don't know this one that has gender times NHIS. Forget about this one. Is just showing the count, like that there are 25. Just to tell you that you had 25 data sets given here. So this one that has gender times NHIS. What this crosstab does is to like the name, to crosstab, to, like I've been explaining since, to check how many female answered true to this question and how many female answered false to this question. How many male answered true to this question? How many male answered false to this question, more or less. So now, from this table that we can see here, this particular table that I just highlighted, that is in blue now, we can see that for the female, the count is that 3 females said true that they have NHIS, while 17 of those 20 females that we have, remember that we had 20 females when we checked the frequency, are saying that it's false, that they don't have NHIS. So now that gives you an idea of how many people that came to claim that day that have that are females that have NHIs. And if you even want to, I don't know, start doing research from there and say, okay, we want to know whether being a male or a female affects you having NHIs. That's something I can, even if I don't know whether it's necessary. Okay, the same thing for male. You'd see that from the ones that we collected. Now, if we use the whole data set, we'll be getting a different answer because the data will be more. That's why I keep referring to the fact that is the data we extracted from there, the 25 data sets, the 25 samples that were collected from that whole data set. So male, 0 people accounted for having NHIS, or rather, they answered true to the question of if they had NHIS, and 5 people answered false to the question of. So that means the whole 5 male that we collected from that sample, none of them have NHIS. Okay, so we don't. The first about this chi-square thing, look at it later. It's in another class. Now we come to hypertension, and it looks like the figures are the same. Now, gender for females, the same thing. 3 people of those 20 females said it's true that you have hypertension, and 17 people are saying that it's false, that like to the question of hypertension. And the same thing happens for male too. 0 said it's true, 5 said it's correct. Okay, I don't think did we ask for diabetes? No, so they didn't give us. Okay, so yes, basically something like that. That's what crosstab does. It gives you that figure of how many people from this. You can use anything. If you have profession, if it's the profession of people that you collected, and maybe you want to know, I don't know, you want to know how many percent of doctors that work here actually ever come to do an X-ray check, or how many percent of us that work in even in this radiography department, how many females come to do a radiography test, and how many people do not come to do a radiography test, or to do an X-ray test, or to do an X-ray scan, all those kind of things. It depends on your research question. Then you now know what to, like, I don't know, the questions to ask or the kind of things to look for. Okay, so now makes me to ask this question. Last time I was asking, and people said that they had used SPSS for different things, but I want to know what the different things that you've used, or the different things, the little research that you've done in your MSc project, BSc project, or even the research that you've been doing, or the research that you even want to do. If one or two people can just tell me what the research question is, so that I'll have an idea of what when you want to do a research, what are the things that, when your radiographer wants to do research, what are the questions that she's asking or he's asking? So someone can answer me, like, what is your research question if you're going to do a research? Or what research question have you worked on before?
Okay, the one I worked on was trying to estimate placental thickness, trying to assess the thickness of placenta at the point of thickness of the umbilical cord at the point of insertion of the plant. What am I saying? Okay, the research question, actually we're trying to develop a nomogram, trying to see, can we use the placental thickness as an indicator for estimating the gestational age. So what we try to do is to measure the placental thickness at the point of insertion of the umbilical cord. So the question is, is it something, what's the relationship between this thickness and the gestational age? That I worked on.
What did you call the age? Gestational.
Yes, the age of the fetus in utero. Because the parameters I use to assess them, they keep increasing as the fetus increases. So you're just trying to say the length, the thickness you will get, can you use it to now say how old the fetus is?
How old the fetus is? Oh, yeah, that's interesting. Yes. So did you say that you have done the research, or you're about to do the research?
I've done. That was my MSc work. That was a long time ago. I even did the analysis myself. I've forgotten almost everything. But now that I'm seeing this screen, it's kind of
coming back. Okay, thank God. What was the result? Can you use it to assess that?
Yes, as at that time it was because there was a positive relationship between the thickness and the GA.
Okay, that's interesting. So you said that what you were using was the placenta thickness and the gestation age, right?
Yes, measuring the placental thickness at the point of insertion of the umbilical cord. Using it to assess
point. Okay.
I know that the placenta is big. You can measure the thickness from so many points. So what's that particular one, that point of insertion was trying to tell exactly where we're measuring from.
Okay. And to know whether it's gestation age. Okay, interesting. Thank you. Any other person? You can, or even someone, maybe a research question that you have come across and you're like, oh, this research question is interesting, or something that you did a while ago, or something that you want to do, you want to find out how this thing works, and you're like, okay, I want to do research on this thing, or I don't know, anything at all. Okay, anyways, as you're still thinking, I'll go back to you. I think it's Priska, right? What's your what do you call it now? Your questionnaire, if you remember, because it sounded like it was a while ago. What were the questions that you had asked, or what were the questions that, or even if you didn't, it wasn't a questionnaire you did. What were the questions? What was the kind of data that you collected? What did you need to know to be able to do a research on this?
Okay, it was measurements. We're trying to now. The question is, what's the relationship between placental thickness and gestational age? So you're measuring that thickness at different ages of the fetus, and now measuring the age. So at the end of the day, you're not checking, is there positive correlation between these two figures or not? So it's entirely a measurement thing.
Okay, thank you. So you didn't ask too much descriptive analysis questions. Okay, anyways, thank you. So yes, that one would come to it when we get to correlation, because I think what you had were two. We would also see that. I'll go back to my screen and we'll just talk about that briefly. What you had were two continuous data, because we're going to get a measurement for the placenta thickness, and we're also going to get a measurement for the gestation age. So those two things are continuous variables, because I want to believe that you didn't have to categorize them. So that way you use correlation. Okay, yes. So you can also explore and see other kind of description that you would have. Okay, for example, now let me go back. If you go to analyze, you'd see descriptive statistics. You can go to descriptive. Now, the only what's the English I'm going to speak now? The only continuous data that we have here is age, right? Yes, more like that. That's the one that we can use. And we want to find the mean, the standard deviation, and the minimum and maximum of it. Okay, let me just press okay. See what it gives me. Which it has been trying to do for us since, so but we didn't want it at that time. Now let's try and see what it gives me. My screen is hanging. Okay, so we see it here. It tells us that very easy. You see me, I was trying to guess when I said that that the lowest age I saw there was 4, and that the highest was about 68. But I don't have to do that guesswork, because by putting SPSS, it just gives me the minimum and the maximum if I want to find out. So it tells me that in case you can't see the table, this table that I highlighted in blue, it tells me that I have, like I've been saying since, we have 25 observations, and it tells me that the mean age of the people in this thing is 36.96 basically, and the standard deviation is 19.57, which is actually a bit high. So it shows that, so what does standard deviation shows? It shows how dispersed is your data. And sometimes when like I said, I was surprised when I saw a 4-year-old in the data, and I also saw somebody of 76. But I can imagine, because probably whoever collected data wanted to just know the patients that we've gotten here, in your time. Let's just collect something about them. But I wonder why they're checking hypertension for a 4-year-old. I don't know. I'm not a medical person, but I wonder why. Anyways, okay. So it now shows us also the minimum age of the people that they collected this data from and the maximum age now. But this is just for our 25 people that we collected. So it's possible that in the whole data set, it's up to I don't person the highest age might be higher than this. It's also possible that this mean would either increase or decrease because maybe the maximum age is no, it's actually increase because maximum age can only be higher. If it's lesser, it will decrease. Okay, so that's that. So now let's go back to this PowerPoint and try to explain some other things there. From primary school, we would already know what mean, mode, and median looks like. We have just seen the mean. Mean shows us the average and and they're called measures of central tendency. You want to more or less see or know that what is the balance of my data set. What can I what can I say is that if I pick out a one observation for my data set, I would most likely, like now from this one that we have, if I pick out an observation from this data set, I will most likely find somebody with an average age of 39 or 36. That's what our SPSS said. So that's what central tendency does. It helps you to see where how is my data looking. It's also a descriptive statistics. You just want to know in the core gravity, in everything, if I look at everything, what can I pick out as data is telling me? So the mean more or less tells you the average age. Now the mean can be a bit biased. That's why sometimes when people look for mean, they also look for standard deviation, because what standard deviation tells you is, and you'd see sometimes that when people are representing mean, they'll put mean plus or minus standard deviation, because that mean just tells you that the average age is this. The standard deviation tells you how dispersed is this data for it to have this average mean. That's like, what are you looking? Your plus or minus, is it too much? If I have an average age mean of 23 and I'm having plus or minus 23, it shows me that, and I'm thinking of the data, the people I collected the data from, it might show you that I think you have an outlier in this data, because why do you have a plus 23? Maybe I collected this data from okay, let me use something lower. I go to a school and I want to find a secondary school and I want to find out the drug use of students there. And when I bring my data and I'm trying to run the descriptive statistics on it, I see that the mean age of students there is 20. But my standard deviation says plus or minus 11. So I'm asking myself plus or minus 11, meaning that probably there's somebody that is about 31 years old there, or 30 years, or I don't know, around that age. And ask myself, okay, is this student that filled this form now, is this person lying, or is this person really 31 years old? Now it depends on you. You're the researcher. You can either remove it or leave it. It depends on what you want to get out of it, and also what you think. For the people that you saw that you collected data from, do you think anyone there is 31 years old? So more or less, how the standard deviation shows you, it shows it shows you like how dispersed is this data that I collected. Is it too dispersed? Do I have to remove outliers because my standard deviation is looking a little bit too big? Now the mode, as usual, which was for me was my best thing in primary school, to find the mode, because they're just looking for the one that is looking plenty, and it just shows you the frequency. How many people in this class are 18 years old? If 18 is the frequency, so that means it also kind of gives you an average. On an average, I'm having more people in this secondary school, these people that I collected data from, being 18 years old, so I can fly with that. Then the median shows you the middle number, the middle, like where does, more or less, what is the middle of my data? Where does it draw its line? What age will I say that, okay, from where is my data cut through? That, and sometimes, most times actually, the mean and the mode, if you have a very well distributed data, that one is another problem. It's the mean, mode, and median should be on the same place. Does it? But it's very rare, because first of all, people, especially when you give out questionnaires, people say all sorts of things. Some people say things that are not true. Some people just want to be funny. and feel what they don't, like, don't know, just say different things. And sometimes when we were collecting research questions, at least people do it a lot in BSc projects. You just, I might want to collect research questions from medical students, but somehow I'm not getting medical students. I just go and meet any random student and say, okay, please fill this data for me. And they don't know the things that you're asking them. So they just feel whatever they want to feel and they give you the questionnaire. And when you're data now start looking for you, you're like, oh, what's happening here? Anyway, so yeah, that's measure of central tendency. What was I saying? So yes, then also measures of variance and standard deviation and range, they are called measures of dispersion. Measures of dispersion, like I said, how far apart is my data stretched, or how close together is it? So now this screen says that there's machine A and there's machine B, and we are trying to see this machine, how reliable is it? Does it produce a consistent radiation dose? And we can see that the range is small. So if the range is small, it shows that when the machine is used, it gives numbers. So sorry. It gives numbers that are close to each other. So let me say, for example, I use this machine to generate something, and I'm getting 16, 18, 19, 20 around those figures. It shows that it's close together, it's not far. And the same thing, if variance is low, it also shows that this data is closely knitted. The same thing with standard deviation. But now, like the second diagram there, the machine B, you can see how dispersed the data that is generated is looking. The variance is high, the standard deviation is high, the range is very large. And you're like, maybe you need to recalibrate this machine so that it's getting, I don't know, it looks like something is wrong with it. Okay. Then okay, what I didn't show you, we'll go back to that screen and we'll see how to generate charts and data, and bar charts and other charts. It's also good to know what kind of chart can I plot with what kind of data I have. Thank God we started with talking about nominal, ordinal, and continuous data. For nominal data, because it's descriptive in nature and it's also categorical, you more or less want to know maybe do a bar chart or do a pie chart just to see what percentage, like gender, using gender, see what percentage of people here are female. And I want to put it in a nice way so that when someone looks at my research, if they don't want to look at the table, they can just go to the image that is there and they already know that, okay, yes, 50% of people here are female and 50% of people here are male, and all those kind of things. Then for an ordinal data, this plot here is called the box plot. It more or less shows you like how the ordinal data is, shows you the highs and low. It shows that this amount of people chose this amount chose medium, this amount chose high, or these people strongly agree, people. And you can also use a bar chart for it too. You can use a bar chart for it. You can use, yeah, mostly a bar chart or a box plot, but a box plot explains it better. Then for continuous variables, it's better to use a line graph when you want to plot a continuous variable, because if you try to even use maybe we should try it. If you try to use a bar chart or a pie chart, I don't even know how it's going to look, because it's going to try to find a column for every number that is on your continuous variable. Like this one that we have now, we have from 4 to 76. It's going to try to find a corner for 4, 5, 6, 7, 8, like that to 76. I don't even know that it's going to run itself because it's going to be tired. Okay, so yes, so a line chart would help it. It would first of all come out as dots here and there. Like this one here, this diagram shows radiation dose and patient's BMI. So you're plotting two continuous variable against each other, and you can just navigate around it. Okay.
Please, I have a question, please.
Yeah, please ask.
Okay, in that box plot, I something that I used to remember. I really do understand the box plot when we use it.
Okay. Okay, I would explain that. Right. Okay, so more or less, a box plot can be used for different things. Sometimes we use it to find how skewed the data is, like what does the data move towards to. And we also use it to find skewed. What I mean skewed is like where the data that you've collected, what are the majority people saying in the data that you've collected, like the questions that you asked. What's it looking like mostly? It's is in the box plot that you'd actually get things like the median, and you also get outliers, right? So now for this one that was shown here, it shows you that here it shows low, medium, and high. Low is in between this 1 and 2. Now, I have no idea what they used to plot this thing, because like I'm pretty sure they just generated it. But this one here, this dot, I don't know if you see my arrow. This dot that is towards the low side tells you that, because the box plot itself is from this line to this line. So this one shows you that you have an extreme outlier at low. So that means there's an observation that had a very, maybe the person chose very low, unlike every other observation. So anybody that had chosen low and medium would fall in between this line here and this middle here. But anybody that has chosen between medium and high would fall in between here and here. But somebody that chose very low or very high would end up being an outlier. End up being some, like, I don't know, like just a data that doesn't really fit into what every other person is saying in the observation, which normally people try to, some people, it depends on the research you're doing. Sometimes people remove outliers because they don't want to see any outlier at all. But sometimes people use it just to see, but it can backfire. Sometimes if you don't remove an outlier from your data, it's I don't know, it makes your results, it is the way it turns your results, because that number, no matter how insignificant it looks, it's, I don't know, if it's still, since you still use it in your data, it affects it. But some people want that effect in their research, so they leave it. So what the box plot does really is to show you the medium point, the middle point, which here is obvious that is 3, then show you outliers that this person, the people outside this box plot itself, these are your outliers, and now shows you the lowest point and the highest point. So it gives you like the range, gives you the median. I don't know if you understand.
Okay. Yes, ma'am. So it means that this plus can actually tilt to either high side or the low side.
Yes, sometimes you can even have that this middle, this box here is even more to maybe the high side or the low side. Or that this line here, this one, I don't know if you're seeing from here to here, is a little bit shorter than from here to here. So it shows that most people that responded to your data chose something on the high side.
All right. Thank you so much, ma'am.
Welcome. Okay. Okay, so our time is basically almost up. I think it's because we wasted a bit of time in the beginning, but we would go through, because I'm supposed to do hypothesis testing, which is another thing that really confuses a lot of people, because first of all, it's very easy. It's not hard to do it at all, like to click on the buttons and do it. But I think knowing what to use and knowing what to test kind of makes people a bit confused. Like, what am I testing? What particular statistic should I use? Am I using a t-test? Am I using an ANOVA test? Am I doing correlation? Am I doing regression? All those kind of things. So what we'll do is that I will do the explanation now. Then in the next class, we're supposed to do chi-square test. Chi-square test is not very bulky. So would also do the practical of when I need us to be doing it together. So I have to figure out why you're not seeing the other sheets, and also every other person's problem. So we'll do the chi-square test and also practicalize the t-test. Because I chose t-test. Well, t-test is like the most rampant test to use. You don't really see. I mean, I was researching on what a radiography research should look like. They had said that most research uses t-tests and correlation. I was like, okay, great. Anyways, but it's ANOVA test and the rest. So now the first thing for hypothesis testing is to is the question, what am I testing? What am I looking for? Like I don't know. Yes, like I said, the question, what exactly am I trying to find? And that helps you to know what to do. Now, the one that is here says, does our new imaging protocol significantly reduce radiation dose? That's the research question. Does our new imaging protocol significantly reduce radiation dose? And for Priska, her question was, can we use the placenta thickness to measure gestation age? So there was something else there. I think I missed that. Something about the umbilical cord. But can we use placenta thickness to measure gestation age? And those are the kind of questions that you see. The first thing to do is to figure out your null hypothesis and your alternative hypothesis. Now, null is more like, it's like the name null, that the new thing that you want to do has no effect on it. So like this one, it says that the new protocol has exactly the same dose as the old protocol. Any difference observed is just random chance, but we can stick with the first sentence. New protocol has exactly the same dose as the old protocol. For Priska's question, it can be that the placenta thickness, the null hypothesis can be that placenta thickness has nothing to do with the gestation age. That would more or less be what her in simpler terms, what her null hypothesis would be, against her alternative hypothesis, which is trying to prove that placenta thickness actually has an effect on gestation age, or rather, placenta thickness can measure gestation age. So those are the things. They're like this versus this, null versus alternative hypothesis. Now we had time. I would have asked you. I had asked before and only had answered, but like to give me research questions, and we'll try to see what is the null hypothesis there and what is the alternative hypothesis there, right? I think I also have a couple of questions that we can use. Now, listen to this research question. It says that does radiation safety training improve radiographers' knowledge? That's the question. Does radiation safety training improve radiographers' knowledge? Now, the null hypothesis can be that more or less there will be no significant difference, or radiation safety training does not improve radiographers' knowledge. In more statistical terms, you see something like there will be no significant difference if radiography's safety training is added or something like that. It doesn't. Nothing's going to happen to the radiographer's knowledge. While the alternative hypothesis we are trying to prove is that when a radiographer is trained on safety, it improves his knowledge. So something like that. Okay. So someone can answer this one, can tell me what the null hypothesis would be and what the alternative hypothesis would be. Do male and female radiographers differ in their years of professional experience? Do male and female radiographers differ in their years of professional experience? So you can just tell me what the null hypothesis would be and what the alternative hypothesis would be. Anybody?
Male and female radiographers do not differ in their years of professional practice, you said?
Yes.
Yes, just to say no, they don't differ. Why the alternative would be that yes, they differ in their years of professional practice.
Yes, something like that. And of course, you can coin it to look to be more. You can statistically you see something like there's no significant difference in the years of professional experience of male and female radiographers, and the other one would be like there is a significant difference in the years of professional experience of male and female radiographers. It should go like that. Okay. So now when you realize what your null and alternative is, you can, what am I using to do it, and what statistics do I use to find out this thing? For you, that's for Priska, it was more like I said, because the two measurements there were going to be continuous data, that's you're going to be scale. It was almost a given that you use correlation. because in correlation you can use two continuous data. But now that we are talking about t-tests, now what does what does t-test do? Sorry, let me. Okay, what does t-test do? T-test is a statistical test used to determine whether there is a significant difference between the means of one or two groups. The means of one or two group. So and it's appropriate when you have, first of all, you have a dependent variable which is normally continuous. Then you can now have an independent variable that can be nominal or ordinal, depending on what you're looking for. So it says here that for comparing two groups, if you have a scale data versus nominal data, and if your nominal data is in two groups, you can use an independent t-test. Now, if you're comparing categories, you have a nominal data versus a nominal data. That means you have two questions I want to ask that are both categorical data. You use a chi-square test. Then if you're trying to find the relationship, like Priska was trying to find between two things, and they are both continuous, that's the scale data, you use correlation. Are we there?
Yes, ma'am.
Okay. Okay. So yes. So number four, t-tests. For t-tests, you'd have most times you'd use an independent t-test for whatever comparison you're using. But sometimes you need to use either a one sample t-test or an independent t-test or a paired t-test. But now that's just extra information. But most times use an independent t-test. And what you should know is that you need to have a nominal data and a scale data to use an independent t-test. Then now, another thing that is important is to know when you finally we'll see it in the next class, when you've analyzed the data and your results is out, how do you now interpret all the numbers that you're seeing there? How do you now know, okay, whether you're going to accept the null hypothesis or you're going to reject the null hypothesis? It's from, first of all, what is your level of significance? Now, level of significance is also kind of called like your confidence level. It's called your confidence level. So most times, it's 95%. Why is it 95%? Because researchers like to give themselves a little bit of benefit of doubt. There's a very small chance that this result that I have gotten might not reflect what the true picture of things. And that's where the remaining 0.5% goes to, or remaining 5% goes to. So that's your level of significance. So your confidence level is that I'm 95% sure that this hypothesis that I am accepting is correct. Like I've done the background work, I've run the data, I've done all these things. I'm 95% sure that it's correct. But now the other 5%, you're more or less leaving it that, okay, there is a 5% chance that if somebody else somewhere does the same thing, the person is going to get a different result. So it's just like benefit of doubt. You find, but most times, I think for things related to human beings, like, let me take for example, maybe when they wanted to, when they are trying to do a test run on a drug, of course, I heard that the first time we try and do with animals before they use a human being. I don't even know that they still use human beings now. I don't know. Anyways, but when they want to do that, they look for a higher confidence level, because this time around, you're not just talking about somebody economy of a nation that can go back. You can find you can do, or you're not talking about a machine, or you're not just doing a regular survey question. You're talking about somebody's life. So you want to be sure that the researchers that are doing this research are 99%, like they have at least maybe 98% confidence level that this thing they are doing, the chances that it's not correct is very low. So that's one thing. So that's what we call the level of significance. And most times, if you want to, anyways, we see that. But if you get a p-value when you run your test, if it's greater than 0.05, then you accept the null hypothesis and say that, okay, yes, the protocol didn't work, and maybe there's something else that can be done. But if it's less than 0.05, then you can also say that, oh yes, that this protocol worked. So that means this thing can be used somewhere else. Okay, so I'm done round talking. I'm done. So who has any question for me? It's already past 8. Any question at all? There's some people I'm not hearing anymore.
Yeah.
I never heard. Okay, it's good. They're here.
Okay, please. I want to ask, what's the difference between SPSS
and what?
Hello?
Sorry, I didn't get that.
The difference between SPSS and PSPP.
Okay, the difference is more like your difference between Excel and Google Sheets. They are owned by two different companies. SPSS is owned by IBM. I'm not so sure who PSPP is owned by, but I was explaining in the first class that I had an issue getting my SPSS on this laptop. And also because PSPP is free, SPSS you have to go through the process of trying to get a license or trying to get a crack version. So yes, so there's no real difference. The interface, if you look at the two interfaces, they basically almost look the same, and the same thing, the same way that your output page is on a different page on PSPP, the same thing happens in SPSS. Your output page is on a different page too. The difference is not a lot. It's just the company that owns them.
All right, thank you, ma'am.
Welcome. Is there any other question? All right, then I think we can end. Chijuke, is there anything else?
Yeah. So let me stop recording first.
Okay, great.